Well, here's a short video on using the discriminant and the quadratic formula. If you're factoring, then and you're factoring these polynomials and you've got a quadratic here, it's really easy to check to see if it's prime. Now, just like a prime number can't be divided by anything other than itself and 1, a prime polynomial can't be factored easily. So as a result, we have to know what the quadratic formula is, and we have to know the standard form so that we can strip out the different coefficient constants and the constant. Um, uh, but the part of the quadratic formula that we're interested in is the discriminant, which is the radicand here. That's b squared minus 4ac. And b squared is this constant coefficient squared minus the number 4 times the constant coefficient of the second degree term multiplied by the constant, the constant at the end. So here's an example of something that you would look at. You'd say, oh, the coefficient here is 1, coefficient there is -2, and the coefficient here, or the constant here is -29. Normally, you would sit there and you'd say, oh, well, what are the factors of 29? And you're, first of all, going to run into a problem there because we're going to think to ourselves that 29 is prime. But even if you don't have that thought to yourself, you might sit there and play around for a little while and wonder why things aren't adding up to -2. And then you double check yourself. You use the discriminant. So here we have, this is this is the b term, -2 squared minus 4, and this is a. And here we have c. This all multiplied, the product of that is -116, but we understand that this is subtraction. Therefore, 4 minus -116 is going to be +120. Problem with 120 is that it's not a perfect square. And so since we're not getting a perfect square out of this, we know that this polynomial right here is prime. Going along with that, you can use the quadratic formula to re-engineer factors. Oh, let's see if I can figure that out a little bit better. All right, well, that's off the screen a little bit. We'll just, when we get to that, I'll move it. All right, so we have to know, again, what the quadratic formula is. We also have to understand standard formula of ax squared plus bx plus c. So here's an example. We might look at this and want to find the factors of 6 and find the factors of 16, and then play around with it. And quite frankly, that is an easier way of doing it than this way. I just wanted to give you an example of where it works. So brute forcing, we might just play around with the factors here and the factors there that add up to that develop into a middle term of -35. But just in case you're enamored with the quadratic formula, we can pump it into the quadratic formula, get each of these terms, consolidate them. Here we have what ends up underneath what the radicand here is 841. And we know that 841 is 29 squared, so it is a perfect square. So we do know that it can be factored. And these are the two options for our x values. This is 64 over 32, which is 2. Therefore, x minus 2 is a factor. And here is the other x value, which is 6 over 32, but you have to simplify it. And in simplifying it, you get 3 over 16. And now what you see here is you have the x coefficient and the term in this simplified fraction. So this is it fully factored. Again, the example that I gave you might have been easier done by brute force, by just factoring the coefficient and the constant, but you can do it. You can engineer it. So hope this helps. Thanks.